Okay guys, this is going to be another one of those quick tips where I'm not answering a question a user has sent my way, but instead I'll be showing you how I completely missed an important option, aka Aaron's flubs. Anyway, as you can probably tell, this will have to do with simulation and more specifically, simulation results. So I'll run the setup and calculation in warp speed here, and as soon as it's done, let's look at what we have. First off, the displacement results look great, and they usually do. The automatic scaling does a fantastic job of representing the results in a gradual way. But as soon as we change to our stress results, I can't really say the same. It's pretty much all blue here, and the thing is that this happens all too much because of stress concentrations and singularities. In the past, to try to better visualize this, I would rely upon a couple of tricks. The first was clipping by sliding the max level down to filter the results. But even then, the top 80% of this scale doesn't really include much of the geometry, so as soon as you get toward the bottom end, all of my results disappear in a flash. So no go there. If that failed to help, my next best solution would be to hide high-stress components. The great thing about this is that they were still used in the simulation ensuring the accuracy I need, but now we're filtering the scale for the component of interest. The problem with this is evident with this assembly. There are a ton of components and bodies, and hiding them is a bit of a pain. So what I learned the other day was that there's a way to manually override the scaling, and it's been under my nose the whole time. And because I don't want you to make the same mistake as me, let me share it with you. You ready for this? To adjust the scaling, all you need to do is double-click on the scale itself. That will bring up an option to key in a max or minimum value. So although this automatically adjusts to about 75 ksi, if I try something lower, my plot will start to tell me more and more about the stress distribution. I don't know exactly the best value to use here, so it's a bit of a guess and check process, but eventually I'll get to something that is just about perfect. Anyway, thanks to Bryce for showing me this, and while I'm at it, I might as well congratulate him for beating me at ping pong for the first time ever. Cheers.